Look at this giant mountain peak. It looks completely frozen in time, right? But beneath your feet, a violent, unstoppable engine is constantly running and churning. Earth is the only known planet that continuously builds massive new mountain ranges. While other worlds die quietly, our planet tears itself apart just to grow. Why does Earth never stop making mountains? Let's uncover this terrifying, deep mystery. To understand this, we must strip away the oceans and the green forests. We live on a thin, fragile crust floating on a sea of fire. This crust is not one solid piece. It is brutally shattered into fragments. These massive fragments are what scientists call the global tectonic plate system. Think of them as puzzle pieces slowly drifting across a hot, viscous mantle. The driving force behind this constant movement is immense, unimaginable internal thermal heat. Deep inside, radioactive decay acts like an eternal furnace, melting the surrounding rocks. Hot mantle material rises upward, cools down, and then sinks back down again. This continuous loop creates massive convection currents dragging the tectonic plates along relentlessly. When these gargantuan plates move, they inevitably crash into one another with force. This slow but brutal collision is the absolute birthplace of all modern mountains. Imagine two cars colliding in slow motion. The hoods crumple and push upward. The Earth's crust behaves the exact same way during a continental plate collision. Take the mighty Himalayas, home to Mount Everest, the highest peak on Earth. 50 million years ago, the landmass of India slammed aggressively into the Eurasian plate. The impact was so tremendous that the crust had nowhere to go but up. This singular massive event forged a colossal wall of rock stretching across Asia. And the most shocking part? This geological collision has not stopped happening yet. India is still pushing northward, traveling about 2 inches further every single year. Because of this, the Himalayas are continuously growing taller, reaching for the sky. But mountains are not just formed by plates crashing directly into one another. Sometimes, a heavy ocean plate dives beneath a lighter continental plate entirely. This brutal geological process is scientifically known as the terrifying subduction zone phenomenon. As the ocean plate sinks deep into the hot mantle, it violently melts. The immense pressure forces this molten rock to blast upward through the crust. This molten rock violently breaches the surface, creating towering, explosive volcanic mountain ranges. The majestic Andes in South America were completely built by this exact process. Layer after layer of cooled lava and ash stack up over millions of years. Eventually, these massive volcanic stacks transform into the breathtaking jagged peaks we see. Even as you watch this, subduction zones are secretly building tomorrow's giant mountains. But there is a third, equally powerful way the Earth forces mountains upward. Sometimes, the tectonic plates are pulled apart instead of being brutally pushed together. When the Earth's crust stretches thin, deep massive faults begin to violently form. Huge blocks of solid rock drop down, while neighboring blocks are thrust upwards. This creates stunning fault block mountains, like the famous Grand Tetons in North America. The Earth acts like a massive conveyor belt, constantly reshaping its very surface. But if the Earth is constantly building mountains, why isn't the whole world covered? Because there is an equally relentless and destructive force fighting against mountain building. Erosion is the great destroyer, slowly grinding the tallest peaks down into dust. Water, ice, and wind wage a continuous, billion-year war against the towering rocks. Freezing water expands inside tiny cracks, aggressively shattering solid boulders into loose rubble. Glaciers carve massive U-shaped valleys, acting like gigantic, unstoppable bulldozers of solid ice. Over hundreds of millions of years, mighty ranges are worn down to hills. The Appalachian Mountains were once as impossibly high and jagged as the Himalayas. Now, they are merely gentle shadows of their former, violently constructed geological glory. This leads us to the grand, eternal paradox of our dynamic planet. Mountains are constantly being born, yet they are simultaneously being destroyed. If erosion won, the Earth would become completely flat, covered by a global ocean. Instead, the internal heat of our planet fights back with brutal, unyielding strength. This constant tug-of-war is what keeps our world alive and radically changing. Without mountain building, life as we know it on Earth could not possibly exist. Mountains act as gigantic barriers, completely altering the global weather systems. When wet winds blow from the ocean, they hit these towering rock walls head-on. The mountains force the air to rise rapidly into the freezing upper atmosphere. As the air cools down, it drops massive amounts of rain and snow onto the land. This creates the great rivers that supply fresh water to billions of people worldwide. Without mountains holding the snow and ice, freshwater supplies would quickly vanish. Furthermore, mountains regulate the entire global climate over millions of years. When new mountains form, rocks are freshly exposed to the open air. These fresh silicate rocks chemically react with carbon dioxide in the atmosphere. Rain washes this locked carbon down into the oceans, trapping it safely away forever. This natural chemical process acts as Earth's ultimate, long-term planetary thermostat. Without mountain building to pull carbon down, our planet could easily overheat like Venus. Or worse, plunge into a permanent, freezing snowball state from lack of greenhouse gases. Mountains are the beating heart of Earth's climate regulation and life support system. Let us look at another fascinating region where the mountains are currently born: East Africa. Here, the massive African continent is slowly tearing itself apart right down the middle. This is the famous East African Rift, a bleeding scar stretching thousands of miles. Magma is pushing upward, forcing the ground to swell, crack, and violently fracture. In a few million years, this land will split completely, and a new ocean will flood in. And on the edges of this giant split, towering brand new mountain ranges are rising. Mount Kilimanjaro and Mount Kenya stand as proof of this ongoing violent birth. Earth never pauses its manufacturing process. It simply moves from one region to another. Even beneath the pitch-black, freezing waters of our deep oceans, mountains are born daily. The Mid-Atlantic Ridge is a massive underwater mountain chain longer than any on land. Here, tectonic plates pull apart under the ocean, letting molten lava ooze out continuously. This underwater volcanic activity builds towering submarine mountain peaks beneath the waves. Some of these underwater peaks grow so tall they eventually break the ocean surface. This is exactly how majestic islands like Iceland and Hawaii were originally forged. Every single square inch of Earth's crust is part of this grand, endless cycle of creation. What about other planets in our solar system? Do they share this restless mountain habit? Let us travel across space to Mars, home to the largest volcano in the entire solar system. Olympus Mons stands nearly 3 times taller than Mount Everest, an absolute giant. So why did Mars manage to build such an unimaginably massive mountain peak? Because Mars lacks active, moving tectonic plates like the ones found on Earth. On Mars, lava continuously erupted from one single stationary spot for billions of years. Without moving plates to shift the hot spot, the mountain just kept growing taller and taller. Earth is completely different. Our moving plates prevent mountains from growing infinitely in one spot. Plates constantly drag mountains away from their magma source, capping their ultimate height. That is why Everest cannot grow infinitely high. Gravity and erosion pull it down. Earth's dynamic system recycles its crust in a grand, perpetual planetary cycle. Old mountains are destroyed, melted down in the mantle, and reborn as brand new peaks. This eternal recycling machine is what makes our planet uniquely alive and habitable. As long as the Earth's core stays hot, the mountains will never, ever stop rising. Next time you look at a towering peak, remember, you are witnessing a living giant at work. Let us gaze into the deep, distant future of our ever-shifting planet. Continents do not stay put. They drift across the globe like giant wooden rafts. Every few 100 million years, all the scattered land masses violently collide together. This colossal geological event forms a monstrous supercontinent, completely reshaping the world. When continents smash into supercontinents, unimaginable supermountain ranges are born. These ancient ranges would dwarf the Himalayas, stretching higher into the stratosphere. Geologists call this recurring planetary cycle the Grand Wilson Supercontinent Cycle. Over and over again, land is pulled apart, scattered, and then slammed back together. And every single time this happens, brand new mountain ranges crown the surface. Earth is a recycling machine that never sleeps, constantly wiping the slate clean. Think about the sheer scale of energy required to lift a mountain into the sky. Trillions of tons of solid rock are pushed upward against the brutal force of gravity. This requires power that dwarfs all human creations combined into a single force. Yet, our planet executes this jaw-dropping feat effortlessly, day after day, year after year. Without this internal fury, Earth would be a silent, dead, frozen rock floating in space. Instead, our world is alive, breathing, cracking, and continuously building its own crown. Every rock you step on has a violent history forged deep within the Earth's core. Every jagged ridge is a monument to an ancient, unstoppable tectonic collision. And this epic construction project will continue long after humanity is gone. The mountains are the physical manifestation of Earth's eternal, beating heart. So, how fast are these mountains actually moving right now as we speak? While they feel entirely permanent to us, they are actually sprinting upward in geological time. Some peaks rise by several millimeters every single year, a massive speed in stone. Millimeter by millimeter, they fight their way out of the crushing grip of the Earth. At the exact same time, wind and ice strip those millimeters right back off. This delicate balance determines the exact height of every single mountain on Earth. If growth outpaces erosion, the mountain climbs higher toward the clouds. If erosion wins, the mountain shrinks, slowly surrendering back to the lowlands. It is a magnificent, unyielding war fought with stone, water, and fire. And our planet is the grand battlefield where this war has raged for billions of years. Think about the human explorers who have challenged these giant monuments of stone. For centuries, climbers have risked everything to stand on top of these giants. When you reach the summit of a great mountain, you feel the raw power of the Earth. You are standing on crust that was pushed from the ocean floor into the freezing sky. Mount Everest itself is composed of ancient marine limestone containing prehistoric fossils. That means the highest peak on our planet was once resting at the bottom of the ocean. What an astonishing, mind-boggling testament to the restless nature of our world. Nothing on Earth stays still for long. Everything is part of a grand transformation. Oceans become mountains, mountains become dust, and dust becomes life once again. This continuous circle of life and rock is the true definition of our living planet. As we reach the final moments of our journey, let us reflect on this immense truth. Earth is not just a rock, it is a hypercomplex, breathing, self-building machine. A machine fueled by radioactive decay, tectonic fury, and endless thermal power. A machine that ensures our world remains dynamic, habitable, and breathtakingly beautiful. So the next time you hike a trail or gaze at a postcard of a snowy peak, remember this. You are watching a violent, magnificent war between the internal core and the external skies. A war that has built every mountain you see and will continue building long after we are gone. The Earth never stops moving, never stops breaking, and never stops making mountains. Because as long as our planet's heart beats with fire, the peaks will keep rising. The mountains are rising right now. Welcome to the restless, magnificent planet we call home.